Yes. Good evening, students. Welcome back to our sessions. Okay, right. Earlier, we already finished 3 sessions from the number system concept. Okay, we have seen the concepts like divisibility rules, right? Divisibility rule and questions based on some questions based on divisibility rules. And similarly, we have seen some counting the numbers topic. Okay, that means the page numbers, how many times that ones, twos will be repeated, and all those things. Okay, these are the things which we have seen in our last classes. Okay, today we will start discussing two more topics which are important for the UPSC. One is how to find the reminders. Okay, and the other one is unit digit concept. See here, students. Actually, we are discussing all the topics in detail, so it is taking little bit more time, but no problem. We will try to continue it in the same manner. If you have any suggestions or any complaints, whatever it may be, if you have anything, please tell us with the help of the comment session, so that we will be trying to improve ourselves. Okay, right. So today we will discuss the concepts of remainder theorem and units digit. If possible, we will solve some problems. Anyway, while discussing the concepts, we will solve some, what we can say, examples or those things. But in general, I will try to solve some more questions from this remainder theorem and units digit concept in the next session. Okay, today our major focus will be on the concept of remainder theorem, how the questions will be asked, what are the chances of asking the questions in many different ways. We will see them. Similarly, regarding the units digit also. If possible, we will discuss the problems. Else, we will have a separate session for this. I mean, for solving the problems of the remainder theorem and units digit concept. Right. Now, we will see. First, we will start with the remainder theorem. Okay. The first and the basic thing of this remainder theorem, which we need to understand, is about the reminders. What are the possible reminders? Generally, when I say that if 17 is divided with 5, if 17 is divided with 5, what is the remainder which we will get here? If 17 is divided by 5, what is the remainder which we will get? Right from our childhood, we have done the same thing. Yes, the thing is 17 5 times. If I divide 17 with 5, 5 3s are 15. Okay, we will subtract here and we will write our answer as 2. We will say directly that the remainder for 17 divided by 5 is 2. Okay, this is correct. There is no wrong in that. What I mean to say is, okay, I can do in this manner also, right? 17, if I want to divide it with 5, instead of going with 3, I will go with 4 for timing. What will happen, we will see. What I will get here, 20. 5 fours is 20, right? And we need to subtract here. When 17 is subtracted from minus 20, what is the remainder we will get? Minus 3. See here, students. Technically speaking, both 2 and minus 3 are the possible reminders. There is no wrong in that. Technically speaking, both 2 and minus 3 are the possible reminders. Both 2 and minus 3 are the possible reminders. But when you want to tell your final answer, intermediate, that means in the middle, while calculating, if you want to write, you can take the negative reminders. There is no wrong in that. But when you express your final answer, definitely we need to convert it into a positive one. Then only we need to say our final answer. That means if this minus 3 is, for example, if you want to write directly now, minus 3 as your answer, we should not do like that. What we need to do is we need to convert it into a positive number. How we can convert it into a positive number? 5 minus 3, what it becomes? 2. 5 minus 3, what it becomes? 2. In this manner, what two things we need to understand here? The first one is negative reminders are possible. Negative reminders are possible. This is the first thing. There is no doubt in that. Definitely negative reminders are possible. Next thing is we need to express the final answer, sir, always in a positive number. Okay, please keep these two things in your mind while calculating in the intermediate level. We can use the negative reminders, but when we need to express the final answer, that means when you want to mark the final answer, for example, for the same question in the if the options are like this, see here 2 -3, both 2 and -3. This is rare case. I am not saying this may be asked, may not be asked, and D, none of this. For example, if they have mentioned the options in this manner, we should go with option A. We should go with option A. Why? Because even though -3 is correct, but we will express the final answer always in a positive number. Positive number. So please keep this thing in your mind. When you want to express the final answer, please convert it into a positive one and then only express the final answer. Okay, right. So from this, what we can understand, negative reminders are possible. Okay. And when we want to express the final answer, our answer should be always in a positive manner. Positive manner. This is the first thing of the remainder theorem. Okay. This is the first principle rule, whatever it may be. This is the first thing of the thing in the remainder theorem. Now come to the second case. Second thing, very important thing in the remainder theorem is when there is a huge calculation, something like this. For example, I will show you 43 plus 70 plus 49 divided something like this by 6. There is a number. What is the remainder for this? So what our remainder theorem tells us is, whenever there is a huge calculation or something like this, find their individual remainders. Find their individual remainders. That means I need to find the remainder for 43 by 6. And similarly, I need to find the remainder for 70 by 6. And similarly, I need to find the remainder for 49 by 6. Okay. We need to find the individual remainders, and after finding their individual remainders, apply the mathematical symbol between them. Whatever may be. If it is plus, it is plus. Multiplication means multiplication. Subtraction means subtraction. Whatever it may be. Simply apply the mathematical symbol between them. For example, see here 43 by 6. What is the remainder which we will get? For time being, I will take all the positive one only for your better understanding. 1. 70 by 6. What is the remainder which we will get here? What 70 by 6? The remainder which we get here is 4. Right? And similarly, 49 by 6. What is the remainder we will get? 1. Right. Now, 1 plus 4 plus 1. I got something a value like this. If I add all these things, what I got here? 6. What I got here? 6. Tell me, is 6, please observe here, will 6 be the final answer? Will 6 be the final answer? Now, no. Why? Because if you divide any number with n, for example, if you divide any number with n, the highest possible remainder will be always what? N minus 1. Highest possible remainder will be n minus 1. Definitely 1. For example, if you divide a number with 10, what is the highest possible remainder possible for us will be 9. For example, if it is 10, it will be divisible, right? Why we need to do? See, remainder means what? Usually, tell me one basic thing. What is mean by remainder? If you cancel it, the leftover thing is called remainder, right? If you are dividing a number with 6, why the 6 will be will be as a remainder here? No, that is not possible, right? So what we will do? We will divide once again with 6. So here the answer will become what? When 6 is divided by 6, what is the remainder? 0. I am speaking about remainders, students. Please be careful here, not the quotients. Don't say that, sir, 6 ones is 1. Why you are writing 0? Actually, the 0 is what? Remainder. I am purely speaking about the remainders here. So please be careful with that. Okay. I am speaking about the reminders. So here, write a note or what, make a note. When you divide a number with, you divide a number by n, the highest possible remainder will be, the highest possible remainder is n minus 1. Okay, when you divide a number with any value n, the highest possible remainder will be n minus 1. If, for example, something like this, in one more example, I will give you one more example for timing. Same, I will write 45 plus 74 plus 90, 45 plus 74 plus 90 divided by 8. What is the remainder? What is the remainder? As I already told you, find their individual remainders. 45 by 8. What will be the remainder? 5. See here, students, so for your better understanding, for timing, I am taking all the positive remainders. If you want, you can take the negative one also. There is no problem. 74 by 8. What is the remainder I will get here? 2. Similarly, 90 by 8. What is the remainder I will get here? 2. So what will be my answer? 5 plus 2 plus 2. But is 5 plus 2 plus 2, if I add all these things, what is the answer I got here? 9. With what number we are dividing? 8. But what is the remainder which we got here? 9. So whenever you come across these type of cases, divide it once again with the same number 8. In this case, we are dividing it with 6, right? So I have divided it with 6. Similarly, here we are dividing it with 8, right? So once again divide it with 8. So what is the remainder here? 1. 1 is here remainder. Once again I am saying 1 is the remainder. Remainder, please remember this. Be careful. 1 is the remainder. When 8 ones are 8, we will be left with 1. Then that one becomes remainder. So from this, we can understand 3 major things here, students. First one, negative remainders are possible. And the next one is we need to always express the given term in the positive manner. This is the second rule of the remainder theorem. And the third one is whenever you have a huge calculation, something like this, we can find their individual reminders. And then we can write the final answer. While writing the final answer, sometimes we may get a value greater than the number with which we are dividing. So in that case, what we need to do? Once again, we need to divide it with the same number. So here what will be our remainder? 1. Here what will be our remainder? 0. Okay. These are the things which we need to keep in our mind while solving the questions of the reminders. This is the basic thing. Okay, these are the basic things which we need to know while solving the reminders. Okay, clear. Now we will move to some examples. Now, okay, fine. If the questions are something. Now, for the same questions, for time being, what we will do is we will try to go with the negative reminders. How we will get our answer? We will see them. Okay, what is the first example which just now we have taken? 43 plus 70 plus 49, I think so, right? Okay, 49 divided by 6. I will take the negative reminders in this case. Let us see what is the answer which we will get if I take the negative reminders. 43 by 6, what is the negative remainder I can take? Minus 5. Minus 5 is the negative remainder I can take. 70 by 6, what is the negative remainder I can take here? Minus 2. Okay, similarly 49 by 6, what is the negative remainder I can take here? Minus 5. Okay, minus 5, minus 2, minus 5. If you add all of them, what I will get here? Minus 12. Minus 12. Okay, minus 12. But tell me, will our answer will be in the negative one? Okay. Can we express our final answer as a negative value? No. For that, what we will do? Here, see here, I have already told you. 6 minus 12. 6 minus 12. Right? Am I correct or not? Earlier, in our first case, what we have done? 5 minus 3, right? In a similar manner. So, what I will get here? Minus 6. Even though after subtracting it, what I got here? Once again, a negative value. So, do the same operation once again. 6 minus 6. What it becomes? 0. What it becomes? 0. So, in this manner, we will convert the negative reminders to the positive one. Positive one. Okay. You getting my point? Right? In this way, we will convert our negative reminders to the positive reminders. Now, for example, we will see the second example. Okay. What is a 45, 74, 90, right? Okay. 45, 74 and 90. When I want to divide it with 8. Now I will take some negative reminders. When 45 divided by 8, the negative remainder which I will get is minus 3. Similarly, 74 divided by 8, what is the negative remainder I will get here? Minus 6. Similarly, here also what I will get here? Minus 6. If I add all these three things, what I will get? Minus 15. Minus 15. But will minus 15 be my answer? No. So what I need to do? 8 minus 15. What I will get here? Minus 7. 8 minus 15, what I got here? Minus 7. Is minus 7 my final answer? No. Once again, I need to convert it into positive 1 by subtracting it from 8. 8 minus 7, what I got here? 1. Right? The same reminders which we got when we have taken the positive and negative one. Okay, for positive also we got the same remainder. Similarly, while taking the negative reminders also we got. Same example, you can take one positive and one negative. There is no wrong in that. For example, see this example. I will take some positive and some negative, depending on my convenience. Okay, see here students. 43 plus 70 plus 49 by 6. First one, negative remainder is smaller, right? Positive remainder is smaller, right? So I will take plus 1. Positive remainder is smaller. Similarly, here the negative one is smaller, right? I will take minus 2. Similarly, here the positive one is smaller value, right? So I will take plus 1. So what I got here? 1 plus minus 2 plus 1. Why I am taking plus here? Because the mathematical symbol between them is plus. If it is into, I will take multiplication. If it is subtraction, I will take subtraction. Okay. Now 1 plus 1, it is 2. 2 minus 2, what it becomes? 0. Okay, is it clear? Now it is clear, I think. You can take completely positive reminders or completely negative reminders, or you can take the mixed one. That means depending on your convenience. If whatever the value which is lesser, if the positive reminder is smaller, take positive. If the negative reminder is smaller, take the negative. Okay, but remember one thing. Always we need to write our final answer in a positive number. And remember one more thing. When you divide any number with, for example, 10, what is the highest remainder possible for us? 9. Similarly, if you divide any number with 15, the highest remainder possible will be for us what? 14. 14. Right? Keep these things in your mind while writing what we can say, writing your final answer. Okay. Right? In this manner, we will solve the problems of the remainder theorem. Problems from the remainder theorem. Okay. Now we will see some examples, ma. Okay. And then we will move to the remaining, next unit digit. Some basic examples from this area. And then we will move to the units digit concept. Okay. Now see here. Okay, fine. This is very good. We will solve them. For example, if the question is based on powers. See here, if the question is only in this manner, everyone will solve it by taking some time. So for example, even if the question is lengthy, it may take some time for you to solve, but we will solve them. Okay. But if the question is based on the powers, okay, if the question is based on the powers, for example, what is the remainder when the question is something like this? 2 power 31 divided by 3, for example. What is the remainder when 2 power 31 divided by 3? So as usual students, just now I have told you, we will find the remainder for 2 by 3 first. Okay, 2 by 3 initially, and then we will solve the problem. Then we will bother about power 31. Okay, 2 by 3. What is the remainder for 2 by 3? This is the area where our negative reminders are helpful for us. For example, 2 by 3, if you go in the general manner, 0 times 0, what is the remainder you will get? 2. That is correct answer. There is no wrong in that. But in this case, if I take 2, what will be my answer? After finding the answer, apply whatever the mathematical operation which was there for us. What we need to do? We need to find 2 power 31. 2 power 31 means obviously a huge number. And once again, we need to divide it with 3. Practically, it is not possible for us in the examination hall to find the value in the examination hall. Because of that reason, our negative reminders are helpful in this case. What we will do is 2 by 3. 2 by 3 means what is the remainder I can take here? 3 ones are 3 minus 1. Okay, minus 1 whole to the power of, what is the value I got here? 31. Minus 1 whole to the power of 31. 1 power 31 is what? 1 only. Okay, minus, and this is what? Odd power. Okay, minus and odd power. What we will get? Minus. Minus and odd power. What is the value we will get here? Minus. If minus with even power, for example, minus 1 whole to the power of 32 means it will 1 power 32 is 1. Minus whole to the power of even power means what it becomes? Plus. But here 31 is odd power. 31 is odd power. Because of that reason, what I will get? Minus only. Okay, so will -1 will be my final answer? Now at some point we have taken minus, okay, and we calculated -1. We got no, -1 is not our final answer. So because of that reason, what we will do? 3 minus 1, what it becomes? 2. So 2 will be our answer. So the remainder for 2 by 3 whole to the power of 31 is 3. 2 by 3 whole to the power of 31 is 3. Remember here, students, our goal should be only one thing. What is that goal? Is the difference between, we should split or do any mathematical operation such that we should do any mathematical operation, and we should bring that to one conclusion, that the difference between numerator and denominator is 1. As 1. This should be our goal. Keep this thing in your mind while solving the questions, especially the questions which are related to powers. Okay. If it is general addition, multiplication case, means it is up to you. You can solve it. Okay. But when the question is related to the powers, please be careful that we should do what all the possible methods. We should think in all the possible ways and try to write the difference between the numerator and denominator as 1. If you are able to write the difference between numerator and denominator as 1 only, we will be able to find the answer quickly. We will be able to find the answer quickly. Otherwise, it will be a huge task for us to find the answer. So please be careful. Always we will try our best, not try. Definitely we need to write the difference between numerator and denominator as 1. Then only we can find the final answer. Otherwise, we cannot. For example, there is a question something like this. Okay, I will give you one more example. 2 power 36 by 7. What is the remainder when 2 power 36 by 7? 2 power 36 by 7. 2 power 36 by 7. This is the question. Okay, now see here, students. What is happening here? In our previous question, anyway, 2 and 3, the difference is directly 1. So we have solved it very easily and quickly. But in this case, if you see the difference between these two things, how much is the difference? 5. If you take 2 by 7, for timing, put this 36 aside. 2 by 7, if you want, for only 2 by 7, I am speaking about 2 by 7. If you want positive remainder, what it becomes? 2. If you want the negative remainder, what it becomes? -5. -5 will be the negative remainder. And after finding them, what we need to do? Definitely there is power, right? So we need to take power 36. Practically, will it be possible for us to find these much huge values in the examination? No, it will be a huge task. So taking directly 2 by 7 is of no use. What we need to do? Then immediately you should think that, is there any power of 2 which is nearer to 7? Which is nearer to 7. For example, 2 power 1, we know it is 2. 2 square, what it is? 4. 2 cube, what it is? 8. Okay, that means instead of 2, if I try to write 2 in 8 here, the difference between the numerator and denominator becomes what? 1. 1. So for that, we need to split the powers. Here, everyone should know how to split the power. This is very, 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 very important. Okay, in the case of remainder theorem. One more thing which we need to know is split. So that means instead of 2 power 36, I should have 2 cube here. 2 cube here. That means the actual power is what? 36. I want 2 cube, 3. So I am dividing 36 with 3. Okay. 36, 12, sorry. 3 12 is 36. And the remainder is what? 0. So now what I can write? 2 cube. The required one is 2 cube. Whole to the power of 12 by 7. 2 cube whole to the power of 12 by 7. See here, 3, 12. We know that in our schooling itself, we have learned a power m whole to the power of n means what we will do? A power m into n. And similarly, there is one more thing. A power m into a power n. This is equal to what we used to do? M plus n. These are the two things which we use for splitting the powers. So how we split it? In this manner. The required is 3. So because of that reason, I am dividing the power 36 with 3. For example, if my requirement is 4, then I will divide 36 with 4. Okay, in that manner, please be careful. So now what I will do here, what happens to my answer now? 8 power 12 by 7. 8 power 12 by 7. So now it is very simple, right? What is the remainder for 8 by 7? What is the remainder for 8 by 7? Directly the positive one, that is 1. Whole to the power of 12. Whole to the power of 12. 8 by 7 remainder is 1 and whole to the power of 12. So what will be my answer here? 1. My answer here is 1. Similarly, we will see one more example. Okay. 2 power 40 by 7. Similar, just I changed the power for the better understanding. 2 power 40. Same question, right? So instead of 40, if I have 2 cube, I can write it as 8. So my requirement is here what? 2 cube as usual. Okay. So now what I will do? I will divide 40 with 3. Okay. 3 13s are 39. What is the remainder I got here? 1. What is the remainder I got here? 1. So now please check this one carefully, how I am splitting the power. So what I am going to do is this value 2 power 40, 2 cube, the required one for me, whole to the power of 13. Whole to the power of 13. In our previous case, there is no problem for us. Why? Because we got the remainder 0. But here we have a remainder as 1. So what I will do is into 2 power 1. This remainder. So we will apply this logic. Anyway, 3 13s are 39. 39 plus 1, 40. I am splitting in this manner. So please see here. In the previous case, we don't have any remainder. We have 0 as a, we got 0 as a remainder. So we didn't bother anything about. But in this case, we have a remainder. So I have taken 2 power 1 here. For example, while calculating, you got a remainder 2. I will take 2 square here. Okay, in that manner. By 7. By 7. So now what happens to this, ma? 8 power 13 into 2 by 7. Find their individual remainders. 8 by 7 and 2 by 7. Okay. Now 8 by 7, what we will get remainder? 1. 1 to the power of 13. And 2 by 7, take the positive one only. If you want, you can take minus 5 also. But it is waste of time. I will take directly 2. The remainder for 2 by 7 is 2. So 1 to the power of 13 is 1 into 2. 1 into 2 is what? 2. So this one satisfied our given conditions, right? We got a positive remainder and a value which is less than 7. So in this manner, so here the important thing which you need to learn is splitting the powers, how you are splitting the powers. See here, a power m whole to the power of n means a power m into n. And similarly, a power m into a power n is equal to m plus n. Okay, using these two things, we are splitting the powers here. The required one is 2 cube. For example, if the required one is 2 power 4 means, we will divide the number with 4. Okay, if there are no reminders means very good, well and good, we can directly solve it. But if you get any reminder, take the excess value as a power here. That remainder as a power here. Clear, right? Clear? So please be careful while solving this type of problems. Okay. We will see some more examples, more basic examples. Okay. Excuse. Right. So simple examples. Quickly we will rewind. We will finish them. Okay. For example, there is a question in this manner. Okay. What it is means 443 power 197 by 7. 43 power 197 by 7. This is the question for us. Okay, this is the question for us. Now, what happens to this? See here, 43 by 7. What is the remainder you will get here? 43 by 7. Directly we can say 43 by 7. The remainder which I will get here is plus 1. Plus 1 whole to the power of 197. So you can write directly your answer as 1. Okay, well and good. This is well and good. Now we will see one more question. Okay. Sorry. (51 whole to the power of 203 by 7). 51 whole to the power of 203 by 7. Now see here. Okay. What is happening here? 51 whole to the power of 203 by 7, right? What we need to do here in this case, what we can do in this case. Now, 51, if I divide it with 7, what is the answer I will get? 2, generally, plus 2, 2 to the power of 203. That is a huge task for us to find that value. Then how we can solve this one? Similarly, I have told you right already, we will try to write the difference between numerator and denominator always as 1, 1. So for in that plan, what I am going to do here, please see here, 49 plus 2 whole to the power of 203 by 7. 49 plus 2 whole to the power of 203 by 7. All right. Now, 49 by 7. What is the remainder I will get here? 49 by 7, what the remainder I will get here is 0. Okay. So, forget about it. Now, I have 2 by 7. 2. So, 2 by 7, the remainder becomes what? 2 itself. 2 itself. And the answer I will get here is what? 203. 203. That means what is the answer I will get? 2 power 203. 2 power 203, definitely a value greater than 7, right? Definitely a value greater than 7. Earlier also we have seen, whenever you get a value greater than 7, what we need to do? Once again, we need to divide it with 7. Why? Because the highest possible remainder for when you divide a number with 7 is what? 6 only. But 2 power 203 is very greater than 7. That means a huge value, right? So 2 power 203 by 7. Now see here, can we write the difference between numerator and denominator as 1? Yes. How we can write? By splitting the powers of 2. 2 cube is 8, right? So here, instead of 203, I want cube. So I am dividing 203 with 3. Our previous example. Just now we have seen in our previous slide. Okay. So 3, 6 are 18. We will be left with 2 and 3 will come here. 3 sevens are 21. We will be left with 2. Now what happens to our power? 2 cube whole to the power of 67 into 2 power. Here we have a remaining value, right? Power 2 by 7. So now what happens to this? 8 power 67 into 4 by 7. 8 by 7. What is the remainder we will get? 1. And what is the power we have here? 67. Good. Into 4 by 7. 4 by 7. What is the remainder you will get? I will take the positive one only. No problem. I don't want to make it complicated. So into 4. So 1 power 67 is 1 and into 4 is 4. So our final answer becomes what here? 4. So in this manner, we will try to find the difference between the numerator and denominator. And we will try to write the difference between numerator and denominator as 1. Then only we can solve the problems easily and quickly. So please, this is the method. Okay. This is the concept. Don't worry. We will solve more questions. But for time being, in this video, in this session, we will discuss the concept only. Okay. As I have already told you. Okay. This is remainder theorem, basic concepts. Okay. We will solve the problems. Okay. These are the things which you need to learn about the remainder theorem. That means splitting the powers, how we need to split and why we need to split. Just now I have told you, right? If the remainder is 1, easily the powers we can solve it. Okay. Remaining things we will see in our next session. Okay. Next we will see the concept of units digit. Okay. One more concept is there in our number system, that is units digit. Sorry. Units digit concept. Units digit concept. Okay. See here what units digit concept says us is very simple concept. For example, there is a addition something like 437 plus 546 plus 948. There is a huge value something like this, and find what is the unit digit of the following. See here students, to find the unit digit of the following, we will not bother about the total number. We will simply concentrate on the units digit. Why we will concentrate on only units digit means, see here 437, 546, 948. To find the unit digit, we will add all the units digits only, right? 7 plus 6, what it becomes? 13. 13 plus 8, it is 13 plus 8, it becomes 20. 1, 21, right? So we will write 2 here and we will write 1 here. That means we will concentrate only on the units digit which is present at the units position. Because of that reason, what I will do is 7 plus 6. What it is? 13. I will not bother about 1. I will go ahead with 3. Why? Because 3 is the units place. Now 3 plus 8. What it becomes? 11. I will not bother about 1. And what will be my final answer? 1. 1. So in this manner, similarly, for example, if the question is something related to product, that means multiplication, 948. Okay. Here also the same thing. For example, if I want to multiply 437 with 546. Okay. What is the basic mathematical procedure? What we will do? 6 sevens are 42. And we will write the remaining things. And when it comes to the next one, that means when I want to multiply with 4, I will not do any mathematical operation to these two. That means I will not disturb these two, right? Further. So the units digit will remain as the units digit only. Okay, the same unit digit. With the same logic, see here, 7 6 are 42. I will not bother about 2. I will go ahead with 2 now. 2 8s are 16. I will not bother about 1. I will go ahead with 6. So my final answer will become what here? 6. So simple thing, apply the mathematical symbol between them and try to find the answer. Okay, if it is addition and multiplication, this is very simple. But usually in examinations, very rarely they will ask the questions based on this one. What they will do is usually, and one more thing, students. Okay, don't worry. I will tell that thing while discussing the problem. What I mean to say is, for example, if there is a product, something like this, a huge product is there, something like 548 into 743 into 494 into 748 into 575. Something like this is there. So don't blindly multiply them. Here we have 1 5, right? 1 5, right? Simply check, is there any even number in this one? Yes, 8 4 8 3 are there. Directly you can say the unit digit is 0. Why? Because when you multiply 5 with any even number, directly you can say that the unit digit is 0. 5 with any even number, 5 2s are 10, right? 5 4s are 20, 5 6 are 30, like this. So in the given product, if the product is lengthier, and if you have 5 and 1 4, sorry, not 4, any even number, 5 with any number, even number, directly you can say that the unit digit is what? Excuse 0. The unit digit is what? 0 here. Okay, please keep this thing in your mind. Okay, when product and addition and multiplication is there, we will find this in this manner. But in some cases, we will have the questions in powers. Okay, powers. That means something like this we will have. What is the unit digit for 537 whole to the power of 433? Something like this we have. We need to find the unit digit of this value. This is a very huge value, right? For 5437 whole to the power of 433 means if you calculate it, you will get some big number here. Okay, but practically speaking, if you want to find with our general procedure, it is impossible for us to find. Then how we can find this one? Means how we concentrate only on units digit in this case. Here also the same thing. We will not bother about the complete number. Our concentration will be only on the digit which is present at the units digit, and we will try to solve it. Now, in that case only, we will see some special cases. First of all, if the unit digit of the given number is 1, for example, there is a number something like this, a huge number. So, for example, a 5-digit number which ends with 0, and whatever the power it may be, what will be the unit digit of the output? What will be the unit digit of the output? 0 only. Why? Because see here, for example, a number something like this, 4950 all to the power of 200 is there, for example. That means you need to multiply 5450 into 54950 into 54950 into like this for 200 times. See here 0 into 0, 0, 0. If you multiply 0 with any number, what it becomes? 0 only. 0 only. Based on that logic only, whatever may be the length of the number, if it ends with 0 and whatever the power it is, what will be our units digit? 0 itself. Similarly, there is a huge number which ends with 1. Which ends with 1. For example, 431 is there. 431 whole to the power of 65, 69 is there. So that means what I need to do? 431 into 431 into 431 into and so on up to 69 times, right? So what I need to do? 1 into 1, 1, 1 into 1, 1, 1 into 1, 1, 1 into 1, 1, 1 into 1, 1. So whatever may be the number, if it ends with 1, whatever may be the power, what will be my final answer? What will be my final answer here? 1 only. 1 only. Similarly, there is a number which ends with 5. Assume that there is a number which is ending with 5. For example, see here, students, 425. Take example, 425 whole to the power of some 30. That means what I need to do? 425 into 425 into 425 into 425 and so on up to 30 times, right? So now what I will do? 5 5s here, 25. We will not bother about 2. We will go only ahead with 5. See here, students, I am writing all these are units digit. Next, similarly, 5 5s are 25. I will not bother about 2. I will go ahead with 5. Similarly, 5 5s are 25. So that means this 5 will be continued, right? So any number which ends with 5 also, the power will be, sorry, the final units digit output will be the same number, that is 5. Similarly, any number which ends with 6. For example, 236 whole to the power of 24 is there. That means what I need to do? 236 into 236 into 236 into and so on like this. 6 6 are 36. I will not bother about 6. I will go with 6. Similarly, 6 6 are 36. I will not bother about 3 and I will go with 6. Like this, it will be passed. So any number which ends with 6 also will get 6 only. See here, what are the digits which we actually have? Total number of digits, 10 digits. What are those? What are the 10 digits which we have? 0 to 9. Right? Am I correct? 0 to 9. We have 10 digits which are from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Out of 10 digits, for 4 digits, whatever may be the length of the number or whatever may be the power, what is the output which we have? The same digits, that is 0, 1, 5, and 6. For 0, 1, 5, and 6, we have the same output. We have the same digit as the final answer. Any number which ends with 0, whatever may be the power, the answer is 0. Any number which ends with 1, whatever may be the power, the answer is 1. Any number which ends with 5, whatever may be the power, the answer is 5 itself. Similarly, any number which ends with 6, whatever may be the power, the units digit will remain 6 itself. 6 itself. Okay, good. Now, what are the digits which we are left here? 2, 3, 4, 7, 8, and 9. 2, 3, 4, 7, 8, 10. Now we will see the next case. Okay, the next is okay, there is a number which ends with 4. Which ends with 4. Okay, let us check this one. Let us check this one. Okay, simple thing. For example, I have 154 all to the power of. I will take small number for your better understanding for time being. Okay, 4. That means I will multiply 154 into 154 into 154 into 154. I will take 6, Don't be get confused. So that is the reason I will take 6. Why? Because 154 and 154 both are same, right? 4 4s are what? 16. Okay. I will cancel 1 and I will go to 6. 6 4s are 24. Okay, fine. Next, 4 4s are 16. Next, 6 4s are 24. Next, 4 4s are 16. 16, right? So what is the final answer I got here? 6. 6. Okay, good. I will put that aside. Now, similarly, I will take 154 whole to the power of 5. Here itself, you might have understood the pattern, but I am writing here. See here. 154 into 154 into 154 into 154 into 154. Why? Because whole to the power of 5. 4 4s are 16. 6 4s are 24. Next, 4 4s are 16. 6 4s are 24. So at last my final answer, what here it is 6 and here it is 6. Sorry, here it is 4 and here it is 6. If you observe the pattern also, either you will get 6, 4, 6, 4, 6, 4, 6, 4, right? So from this, what we need to understand is for 4, we will have only two chances. Either we may get 4 or else 6. Either we may get 4 or else 6. It depends on the power. It depends on the power. 4 if n is odd. The same 4. For 4, we will get the same 4 if n is odd. See here, for all odd powers of n, we will get the 4 only. For 5, 7, if you cross check it, you will get. And similarly, 6 if n is even. Okay. Here 6, right? 6. For even powers, we will get 6. For odd powers, we will get 4. How you people will remember is 4 power 1 and 4 square. This is odd and this is even, right? 4 power 1 is 4 itself. 4 square it is 16. This is even power, right? So we will consider only the units digit. So take it as 6. In this manner, try to remember. Don't by heart it 4 and 6, 4 and 6. You may get confused. 4 power 1, it is 4. So if n is odd, 4. 4 square, it is 16. 2 is even, right? So if the power is even, we will get 6. Okay, remember this thing. Now, similarly, any number which ends with 9. Which ends with 9. Same logic, ma. Okay, same logic. Same logic. Here also the same 9 if n is odd. If n is odd. And similarly 1 if n is even. Okay. Similar to 4. 9 power 1, 9 square. 9 power 1 is 9 itself. Okay. 9 power 1 is 9 itself. 9 square is 81. 81. We will take only the units place, that is 1. So in this manner, for 4 and 9, we will have two chances. What are those? 4, 6 and 9, 1. Don't by heart them. Simply remember the first two powers. 4 power 1 is 4. 4 itself. 4 square is 16. So 6. 1 is odd power, 2 is even power. Like this. Similarly, 9 power 1 is 9. That means 1 is odd power. If it is odd power, you will get 9. 9 square is what? 81. So 1. So if n is even, then it will become 1. So from this, what now we have 6 digits are completed, right? For 0, 0, for 1, 1, 5, 5, 6, 6. For 4 and 9, we will have two chances each. For 4 and 9, we will have two chances each. Two chances each. Right? Now, similarly, what are the things which left now? With what digits we are left here now? 2, 3, 7, and 8. These are very, very important. Okay, why? Because for those, if in the previous digits, for 0, 1, 5, and 6, very simple, directly you can say. For 4 and 9 also, by observing the power, odd power or even power, we can say. But when it comes to 2, 3, 7, and 8, we will have 4 chances for each number. For example, I will tell you, please observe here. 2 power 1 is what? 2. 2 square is what? 4. 2 cube is what? 8. 2 power 4 is 16. Next, 2 power 5, what it becomes? 32. 2 power 6, what it becomes? 64. 2 power 7, what it becomes? 128. Okay, 2 power 8, what it becomes? 256. If you go 2 power 9, it becomes 512. And so on. If you observe here, 2, 4, 8, 6. 2, 4, 8, 6. Okay. For 2, we will have 4 chances. 2, 4, 8, and 6. I will tell you how to write when we need to choose which value as our answer later. But for 2, we have 4 chances. What are those? 2 power 2, 4, 8, and 6. How you will remember? 2 power 1, 2. 2 square 4. 2 cube 8. 2 power 4 is 16. Anyway, we want only the unit digit. So it is 6. So it is 6. Okay. Right. Good. For 2, the chances are 2, 4, 8, and 6. Similarly, for 3, we will see 3 power 1, it is what? 3. 3 square, it is 9. 3 cube, it is 27. 3 power 4, it is 81. 3 power 5, what it becomes? 243. 3 power 6, I don't know directly, but what we will do? 3 power 6 means 3 power 5 into 6, right? I will multiply with one more 3. 3 threes are 9. I am writing only the unit digits here, not the complete answer. So please be careful. I am writing only the unit digit from here onwards. 3 power 7, what it becomes? 9 threes are 27. That means I need to multiply with one more 3 right here. 27. So I will write 7 here. 2 will go as a carry. Similarly, 3 power 8. I need to multiply this value, this huge value with one more 3, right? If I multiply 7 with 3, what I will get? 1. If you observe here also the same thing, 3971, 3971 will be repeated. 3971, 3971. In this manner, the numbers will be repeated, the unit digit numbers. So for 2, the repeating are 2, 4, 8, 6. For 3, no need to by heart them. Remember the first 4 powers. For small numbers only, right? 2 for 2, anyway you will remember. 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16. We want unit digit, so we will take 6. Similarly, 3 power 1, it is 3, 3 square is 9, 3 cube is 27, 3 power 4 is 81. We all know up to here. So 3971. You can easily remember them. Okay, now next one. 7. 7 power 1, what it is? 7. 7 cube, what it is? 49. 7 power 5. Sorry. 7 square is 49. 7 cube. 7 cube, what it becomes? 343. 7 power 4, I too don't know directly, students. So I need to calculate. I don't want to waste the time. So 3 power 343 into 7 means I need to multiply one more 7 here. So I will get a number which ends with 1. Right? 7 3s are 21. That 2 will go as a carry and I will be left with 1. Similarly, 7 power 5. That means I need to multiply this value with one more 7. What is the unit digit? I will get 7. 7 power 6. Similarly, 7 sevens are 49. 4 will go as a carry. Next, 7 power 7, 3. 7 nines are 63. 6 will go as a carry and 3. 7 power 8, once again, 7 into 3, 21. I will get 1 and 2 will go as a carry. So now what are the numbers I have here? 7, 9, 3 and 1. Okay, 7, 9, 3 and 1. So anyway, up to cubes, mostly everyone should remember the cube values of at least 10 members, 10 numbers. Because of that reason, I am writing in this manner. So try to remember this one. Okay, nothing that too very simple. If you write 7 power 4 means what? 7 cube into 7. 7 cube we know 343 into 7. 7 3s are 21. Anyway, we want only the unit digit, so we will take the unit digit. In this manner, try to remember it, but please don't by heart them. If you by heart them, definitely in the examination all, you may face difficulty. So instead of that, better to learn as a concept-wise value. Okay, next. 8 power 1, it is 8. We know 8 square is what? 64. 8 cube, 512. Right? 8 power 4, I too don't know, but I need to multiply 8 with 2, right? So what is the unit digit? I will get 6. 8 2s are 16. That one will go as carry and 6 I will be having. Next, 8 power 5 means I need to multiply this way number with 8 here. So 8 6 are 48. I will get unit digit as 8. Similarly, 8 power 6. If I multiply with 8, what is the unit digit? I will get 4. 8 power 7. I need to multiply 8 with 4, right? 8 4s are 32. 2 and 3 will go as carry. Next, 8 power 8. As usual, when I multiply 8 with 2, what is the unit digit? I will get 6. So 8426, 8426 is the repetition value which we are getting here. Okay. 8426, 8426. Okay, no need to by heart them. Remember the first 4 powers. Anyway, for 2 and 3, easily you will remember the first 4 powers. For 7 and 8, you can remember up to 3 powers. For 4th power, into same number, right? Just to do one thing, so easily you will get the answer. Okay, clear? These are the 4 chances for 2, 3, 7 and 8. 2, 3, 7 and 8. Okay. Sir, in the earlier case, by seeing the question, for these 4, by without seeing anything and whatever are the power is or do anything, directly we can say the answer. Okay, well and good. In the case of 4 and 9, we will observe the power, whether it is even power or odd power, and we will mark our answer. That is also well and good. But in this case, we have 4 chances in each question. Oh, sorry, for each digit. For 2, we have 4 chances. For 3, we have 4 chances. See here, these are repeating, right? These are repeating, right? Repeating after how many numbers, ma? The same thing. 4. For every 4 numbers, the same thing is repeated. That means what one question I have given, right? Early 5437 whole to the power of 433 is the example which I have given you earlier. So for 7, for every 4 times it is repeating. But what is the power we have here? 433. So as this is repeating for 4 every time, whenever you see any number which ends with 2, 3, 7 or 8, 2, 3, 7 or 8, simply divide the power with 4. Simply divide the power with 4. Simply divide the power with 4. So that means 433, I need to divide it with 4. Why only 4 means these are repeating for repeating once again after 4 numbers. Okay, after 4 numbers they are repeating, right? Because of that reason I am dividing it with 4. Now 4 ones are 4. Okay, well and good. Remainder is 0. 3 will come here. Okay, 3 is not divisible, so I will take 0. So one more 3. I'm taking 4 8s are 32. What is the remainder I am getting here? 1. What is the remainder I am getting here? 1. So now you need to take what is 4 power 1? Sorry, not 4 power 1. What is the remainder I got here? 1. What is the remainder I got here? 1. 1, right? So 7 power 1. Take 7 power 1. What is the unit digit here? 7. So our answer will become what? 7. Our answer will become what here? 7. Our answer becomes here 7. Okay, are you getting my point? Why we are dividing? Simply divide the power with 4. Why only with 4 means for every 4th time it is repeating. So what is the remainder I got here? 1. Okay. And then next is remainder is 1. So I will take the remainder as a power. 7 power 1 is 7. So directly our answer anyway unit digit is 7 itself. Okay, clear. Now, for example, one more example is there. 438 whole to the power of 424. 424. 438 whole to the power of 424. 8, right? For 8, just now we have seen 4 chances. Which chance I need to take? We don't know. What I have told you, divide the power with 4. So 4 tens, 4 ones are 4. 0 I will get here. Okay, 0 times 2. Okay, next one. I will take it as 4. Okay, 6 are 24. What is the remainder I got here? 0. In the previous example, I got 1. So I have asked you to take 7 power 1. Here I got 0. Here I got 0. Sir, should I take 8 power 0? Then it becomes 1 now, sir. No. Okay. Please be careful. Whenever you get the remainder as 0, take the 4th power. Take the 4th power. Take the 4th power. Okay, take the 4th power. That means you need to consider 0 as 4. You need to consider 0 as 4. So please be careful. If the remainders are 1, 2 and 3, there is no problem. When you divide a number with 4, what are the possible remainders which we have? When you divide a number with 4, 0, 1, 2 and 3. For 1, 2 and 3, there is no problem. Directly you can take. If it is 7, if the unit digit is 7, take 7 power 1. If the unit digit is 8, take 8 power 1. Similarly, if the unit digit is 2, take 2 power 1 or 3 power 1, whatever it may be. If the remainder is 2, take 7 square, 8 square, 2 square or 3 square, depending on the unit digit. But if the remainder is 0, take the 4th power. Take the 4th power. Please remember this one only. Okay. Divide the power with 4. If the remainders are 1, 2 and 3, that is fine. You can directly take the respective powers. Units digit. For example, you got remainder as 3 and you have unit digit as 3. So what you need to take? 3 cube. 3 cube is what? 27. Forget about 2. What is the unit digit? 7. So 7 will be your answer. Okay. For the same 3, if you got the remainder as 0, then what you need to take is don't take 3 power 0. Take 3 power 4. Why I am saying 3 power 4 is this is nothing but similar to our clock. Clock. You can say 12:30. Okay. 12:30 a.m. or like this also, right? In the midnight. Did you get my point? Both 12 and 0 is same in the clock. Okay, see in the same manner for in the round robin process. Actually, why we are why we are dividing with 4, that's number 4, this values are repeating for every 4 times, right? Like a clock, in the similar manner, fourth power 4 or 0, both are same. For example, if you take consider this as powers, okay, 1, 2, 3, 4, or in any way this only will become 0. 0, 1, 2, 3, 4, or 1, 2, 3, 4. 0, 1, 2, 3 or 1, 2, 3, 4, both are same. So because of that reason, if you get the reminders as 1, 2, 3, it is fine. You can directly take the values without any confusion. But if you get the remainder as 0, take the fourth power. This is the only thing which you need to remember here. Okay, is it clear now, students? Units digit, this is the concept, how to find the units digit. Okay, if the units digit is 1, 4, 0, 1, 5 and 6, there is no problem for us, we can directly take those numbers. If the units digits are 4 and 9, there will be two possibilities for us depending on the value of n, that is power. If it is odd power, we will have one answer. If it is even power, we will have one answer. Okay. Similarly, for 2, 3, 7 and 8, we will have 4 chances. Why 4 chances means this is the reason. And you need to divide the power with 4, and by observe the remainder. If the remainders are 1, 2 and 3, take their powers directly. If the remainder is 0, take the fourth power. So this is the concepts regarding units digit and remainder theorem. So please, I think this is the 4th session. In the 5th session, we will solve the problems of this remainder theorem and units digit concept. Okay. If you have any doubts or any suggestions, please tell us in the comment section. Okay. We will keep those things in our mind and we will discuss the concepts. See, students, definitely I am spending more time in this number system. The reason is only one thing. They are asking many questions from this number system. Because of that reason, I am spending more time. So please be patient and listen all the sessions. Then only you will have a clear idea. Else there is no use. Right? Thank you very much. We will see in our next session.